we're going to take a few minutes and talk about the reciprocal trigonometric ratios. So if I have an original fraction or ratio a over b, the reciprocal, or to reciprocate, the reciprocal is just the flip. I just take my a over b and I flip it upside down, b over a. That's the idea. So, if I had 2 over 7, the reciprocal would be 7 over 2. So looking at our fractions SOHCAHTOA, we have sine, opposite over hypotenuse, cosine, tangent, and so on. For sine, we chose opposite over hypotenuse. And if we go, way back to the very, very beginning, the reason why we chose that was because the opposite was the height. Was the height of some kind of, we were trying to find the height of a tree or the height of a building or something. And that's why we started dealing with this opposite side. It was an unknown height that we couldn't determine. So we chose to have height, and we liked having that unknown h on the numerator of our expressions. So that's where it all sort of originated from. But if we look here, we have sine, cos, and tan. We could actually flip these over. Okay, we know that sine theta is opposite over hypotenuse. Okay, if I flip that and made it hypotenuse over opposite, okay, if I flip the 1 over sine ratio, I can do that mathematically. Just like I said, I could have 2 over 7 or 7 over 2. Sure, I could flip it. We can do that with our 3 primary trig ratios as well. We can flip sine, cos, and tan. So if I flip sine, it has a new name. It's called cosecant. If I flip cosine, it has a new name called secant. And if I flip tangent, it has a new name called cotangent. Now, in terms of memorizing this, I think the tangent cotangent is probably the easiest one, right? Tan, cotan, or flips. And with these, unfortunately, I thought it would have been cool. Like if sine was the flip of secant, and if cosine was a flip of cosecant, you could remember that they both start with the same letter. Unfortunately, that's not the case. It's the opposite. So sine ends up being the flip of cosecant, and cos ends up being the flip of secant. So we have our 3 primary trig ratios, and we have these 3, they're called reciprocal ratios, which are just the flips of sine, cos, and tan. Everything else works exactly the same. So for example, I'm going to write all 6 trig ratios. I have theta, my hypotenuse is 5, my height is 4, my base is 3. My scale is a little off, but it doesn't matter. So the 6 trig ratios are sine. I know sine is opposite over hypotenuse, got it. Cosine, adjacent over hypotenuse, right? Tangent, opposite over adjacent, got it. Cotangent now is just the flip. So 4 over 3, cotangent is 3 over 4. Okay. Secant is the flip of cosine. So 3 over 5 becomes 5 over 3. And cosecant is just the flip of sine. 4 over 5 becomes 5 over 4. That's it. That's how you write the 6 trig ratios. Now, the question, of course, we're going to see is determine an angle given a reciprocal trig ratio, not a primary trig ratio. So suppose you're given cosecant of A is 8, and you're going to be asked to find the angle A. Of course, you're saying there's a big problem with this, and we all know what the problem is. We don't have a cosecant button on our calculator. Okay, none of us do. So, and we really don't have any of the reciprocal ratios on our calculators. So to be able to solve this problem, we have to actually convert it back into sine. So I know, because cosecant is the flip of sine, I'm going to flip cosecant into sine, and I'm going to flip the 8 into 1 over 8. I just flip both of them. I flip basically the number, and I put the ratio back into sine. I do this because I have a sine button on my calculator. And then I use sine inverse, second function sine, and that gives me my angle, 7 degrees, or property of sines, 163 degrees. Now, interestingly, I just want to show you, and this is, I know it's looking complicated, this is getting a little bit beyond what we're going to do, but I want to show you what these values are. So here's my triangle, 30 degrees. Here's my adjacent, which is 0.5. So the cosine of theta, excuse me, the cosine of theta is here. Oh, here we are, sorry. The cosine theta is this distance here that we've seen, and the sine of theta is this distance here. So that's the cosine, that's the sine. The tan of theta is this distance. If I were to draw, here's my triangle, if I were to draw a circle, if I were to draw a straight line that just touches the circle that straight line hits the y-axis and the straight line hits the x-axis, then the tan of theta is the length of this line there to there, which we could need in some kind of problem solving. The cotangent theta is the length of this section from there up to there. It's that part to that part, which is kind of neat. Secant ends up being the length of here over to here, to the point where that line hits the x-axis. And cosecant ends up being the length from the horizontal all the way up to the point where that straight line hits the y-axis, which is kind of interesting. Now again, these values here, we really won't be seeing these for a while for us, if at all, to be honest, but we'll see. Okay, take a look at page 246.